Welcome back, folks. In today's class, I'll continue talking about the complex numbers. So complex number, that's what we were talking about. And in the last class, we talked about how to write the complex number, how to add them, subtract them, multiply them. And if this is a complex number, 3 plus 4 iota or 4j, what we did was, let me just quickly look into j was in front. Yeah, j was at the end. So if this is a number given to me and then I divide it with something like 7 minus 2j, what I will do is I will take the conjugate of the denominator. Basically, when we are saying the denominator, uh, divide, when we say the divide, it means we are taking the conjugate of the denominator. So 7 plus 2j, and this will be 7 plus 2j, and then we can apply a square minus b square formula. So this will be 7 square minus 2j square, and then 3 plus 4j multiplied by 7 plus 2j on top. And then I'll use the simple conventional algebra, 3 multiplied by the whole parenthesis, 3 multiplied by 7 plus 2j, and then 4j plus 4j multiplied by 7 plus 2j. And then on the bottom it is 49 minus 2 square is 4, which will be plus 4. And then I will write it as 7 times 3 is 21, and then 3 times 2 is 6 j, and then this is 4 times 7 is 28 j plus 4 times 2 is 8 j square. And if anyone who is confused why I wrote it as plus, because j square is -1 and negative times negative will become plus down here. And this will be 53 on the bottom, and then I will write it as 21 plus these two. If I add these two up, let me just quickly say that, yeah, this all in addition. 28 plus 6 is 34j, and minus 8 on the top, because j square is -1 one more time. So 53, this will become, this is 21 minus 8 will become 13. 13 plus 34j divided by 53. That will be the answer. So that's what we talked about in the last class. And just one more thing which I wanted to share with you guys. When the complex number is written in this form with the real number and uh, imaginary part, this is also called rectangular coordinates. This is rectangular form. Okay, rectang, rectangular, ULAR, rectangular form. Yeah, so of a complex number. That's what we talked about in the last class. Now, in today's class, I will talk about the polar addition and polar subtraction of the complex numbers, and also multiplication and division. So basically, I'm going to talk about chapter number 12.4. So you don't need to worry about chapter 12.3. We will do the chapter 12.4, and you will surely find some questions from 12.4 on the exam too. So please make sure you are paying attention to this. So polar form of a complex number. So when we write the polar form, we write x equal to, so if I talk about the trigonometric functions, first of all, so this horizontal axis is x, this is y-axis. Okay, so if this is a vector given to me, and around the y-axis we represent the imaginary part. So if this is a vector given to me, which can be x plus anything, x plus y iota or yj. Now if I break it down, this will become y portion, this will become y, and down here this portion becomes x. Now x value will become r cos theta. Isn't that what happened in the trigonometry also, whatever we've learned in the couple of weeks ago? So this value, if this is r, so this, if I wanted to represent x in form of r, and this angle, if I represent it as theta, so this will become r cos theta, and then y value will become what? Y value will be r sine theta, and then r square is equal to, again I can apply the Pythagoras theorem, it will be r cos theta square plus r sine theta square, and I can take r square common, this will become cos square theta plus sine square theta, and then r square times 1, so that is r square. That's how we can also compare that whatever we've done is right. And then if I have to find this angle, I can find by using tangent theta, sine theta, cosine theta, whatever you can want to use, you can use that. That is y upon x. Theta value is tangent inverse y divided by x. Now the polar coordinate for x plus iota y will become r cos theta plus j sine theta. And how we reached to this one, what we did was, it was written, it was x value was r, it was written like this, r cos theta plus iota, y value was r sine theta. So I've taken r common, cos theta plus sine theta. Okay, iota or j, again I have a bad habit of calling it as iota. So this is how we reach to this thing. All right, now what we're going to talk about is the addition and subtraction of the uh, complex number in polar coordinates. And before I jump into that, I will also represent how to write a given complex number which is given in the rectangular form, uh, how to write it in the polar form. So 3 plus 4j is given to me. I wanted to write this number into the polar form. So this means it is like this. So this is like this. So this portion is 3 and this portion is 4. So if this portion is 3, this portion is 4, this will become 5 because of the Pythagorean theorem. So 3 square plus 4 square, and square root of that number is going to give you r, which is 5. Okay, so r value came out to be 5, and I will write it as 5 cos of theta, this angle theta. So theta is tangent theta equal to 4 divided by 3. Theta value will be tangent inverse 4 upon 3. The angle will be 53.1 degrees. So 53.1 degrees. Make sure your calculators are in degree mode, not in radian mode. So cos of 53.1 degree plus sine of 53.1 degree. That's how we can represent the rectangular coordinate into the polar form. Now we will talk about the addition and subtraction of the polar coordinates. So if we are given, one more thing I wanted to tell you is you can also write it as, this was 5, so we can also write it as 5 at an angle of 53.1 degrees. Okay, which means the same thing. 5 means radius and the angle is 53.1, and then if you wanted to write it in the complete form, cos of 53.1 plus sine of 53.1 degrees. Right, so this is the short form of writing the polar form. Now if I'm given a question like 3 angle 40 degrees, how can I write it in the complete form? This can be written as 3 cos of 40 degrees plus 3 sine of 40 degrees, but j in front or j at the back, wherever you wanted to put it, doesn't make any difference. And then you can take 3 common, cos of 40 degrees plus j sine of 40 degrees. All right, let's now dive into what we were talking about: addition, subtraction, and multiplication and division of the polar uh, polar complex numbers, polar form of the complex number. So I'm going to start with I'm gonna start with the question, which I'm gonna try and look into the book. So we are given a question which is, let me see, it's just gonna try and find it. So yeah, so I've been able to find the division question, multiplication and division. Let's do that first, and then once I'm gonna find the addition and subtraction, we'll do that one too. So multiplication, first of all. So I wanted to multiply 3.61 at an angle of 36.3 degrees, 0.3 degrees, and 1.41 at an angle of 315.0 decimal 0 degrees. So these are the numbers given to me. I wanted to multiply these two numbers. So 3.61, I can write it. If I wanted to multiply them, what I'm going to do here is I can directly multiply the R values. These are R values. And then I can add the angles. I can add the angles. That's going to give me the final result. So this will be 3.61 multiplied by 1.41, and then angles can be added up, as I said to you. So 315 plus 36.5 degrees. I can add them up. So if I do the math here, 3.61, 1.41 here, so this will be 3.61 multiplied by 1.41, which is 5.09, and then angle will be 315 plus 36.5, which is 351.5 degrees. So that will be the final angle. Now let's try and do one more question on the multiplication. So I'm gonna change the angle. So 3.61 at an angle of 56.3 degrees and multiply it with 1.41 at an angle of 315 degrees. Okay, one of the angles I've changed. So again, you multiply these two, that's going to give you 5.09, and then you can add up the angle 56.3 plus 315 degrees. That's going to give you 5.09 at an angle of 371.3 degrees. Now the new angle is bigger than 360 degrees, so I can just write it in form of the I forgot the name. One is called principal angle, another one is called just word is not coming to my mind. Reference angle. Yeah. So this reference angle form, that will be 11.3 degrees. 11.3 degrees. You can write it like this also. Okay. But if the angle is between 0 to 360, we can leave it as it is. Okay, so now we're going to talk about the division of the polar form. Division, Division, division of the polar form. So if I am given the same numbers, so the question is 3.61 at an angle of 56.3 degrees divided by 1.41 at an angle of 315 degrees. So in division, you just divide these two numbers and then subtract the angles, and you will subtract the angles. So this value will be 3.61 minus 1. Well, divide 1.41. So let me do it on my phone. So this will be 3.61 divided by 1.41, which is 2.5 1.56 at an angle of 56.3 minus 315 degrees. So 56.3 minus 315, which is a negative of 258.7 degrees, a negative angle. So a negative of 258, which means this angle will be equal to how much? So 360 minus that value, this angle will be equal to 101.3 degrees. And angle, you can keep it to 1 decimal place. This value you can keep it to 2 decimal places. Okay, I won't deduct any marks for decimal places, just to let you know. So that's how you do the division of the two numbers in the polar coordinates. Now the next one will be addition of the numbers in polar coordinates. So if I take a number 1.563 at an angle of 37.56 degrees, and I wanted to add it with 3.827 at an angle of 146.23 degrees, how can I add them? So when I'm adding, I cannot do it as simple as I did it in the division and the multiplication. Multiplication, you multiply these numbers and you added the angles. In division, you divided these two numbers and subtracted the angle what was on the bottom from the top. And now I wanted to add the numbers, so I have to write them in the proper polar form. So that was 1.563 at an angle of cos of 37.56 degrees and plus j sine of 37.56 degrees plus 3.827 cos of 146.23 plus j sine of 146.23 degrees. That's how you're gonna write it as. And now if I wanted to add the two numbers, before adding I have to multiply this with this, this with this, this with this, this with this. So cos 37.56. So if I do the math, cos of 37.56 multiplied by 1.563, that's going to give me 1.239. And if I multiply this number with this, that's going to give me the value as 0.9528 j minus 3.1813, this value when you multiply these two. And then this is actually 140, so don't confuse yourself, this is 146, cos of 146.23 multiplied by this number. So this, when you multiply them, you're gonna get 3.1813 plus the next value is 2.1273 j. And now you can collect the like terms. These two are like terms, these two are like terms. So the value will be negative 1.9423 plus 3.0801 j. Okay, and you can keep the j in front also or j at the back. It doesn't make any difference to me. Now here, how I'm going to convert it into polar coordinate one more again. So I have to find the r value one more time as we started doing it in the beginning. So r value will be square of this term plus square of this term. So negative 1.943 square. Please make sure you square the negative also, otherwise your answer will be wrong. 3.0801 square, and then r value will come out to be 3.641. And once we got the r value, we're going to find the angle tangent theta, which is equal to y component upon x component. So y component is this is y component, 3.0801 divided by 1.9423, and we're going to get the angle as, let me do the math. So I will show you how we're going to get the angle. This is a little tricky. So second function tangent inverse 3.0801 divided by 1.9423. I got the angle as 57.76. Now this angle which I got, notice I didn't take this negative when I was doing my work. So negative will gonna tell me this angle is with respect to this side, negative, or because the x component is negative. X component is negative, so I've drawn it on this side. Obviously y component will be like this, so the angle, this angle comes out to be 57.76 degrees. If I add, or if I subtract this one from 180, that's going to give me 122. So the principal angle theta will be 122.334. Again, you can keep it to one decimal place also. So this is actually 2, not 3 4, 2 4, 2 4. And now this is the angle I got, and then I can write the final answer. R value is 3.641 at an angle of 122.24 degrees. That will be my answer, or 3.641 cos of 122.24 plus J sine of 122.24 degrees, and that's how you can write your final answer too. So hopefully you were able to understand how you gonna add the coordinates, and then the subtraction gonna remain exactly the same. Only difference will be here you were adding the two numbers. If I use the subtraction, so you will start subtracting. So actually the same process gonna be followed in this one. Here I was adding. If I subtract the numbers, so when you multiply, this was a negative number, this may become now a positive number. So that's how you're going to do it, because cos of angle 146, which is in the second quadrant, so that's why this value came out to be negative, and negative was positive. And that's how you're gonna get the final answer by doing the same process again. So hopefully you were able to understand this thing. Let me do one problem on the subtraction also, so that you can actually understand it in a little better way. So I will take a question on 15.9 at an angle of 142.6 degree minus 18.5 at an angle of 71.4 degrees. Now, what I'm going to do is, I'm going to write it as 15.9 angle cos of 142.6 degrees, and here plus sine of 142.6 degrees. Notice I haven't put a negative here. This will always remain plus, minus 18.5 cos of 71.4 degrees, and plus j sine of 71.4 degrees. And now I can simplify it. This is going to go with this. So if I do the math, 15.9 cos of 142.6, which is negative 12.63, because this is in second quadrant, plus sine 142.6 multiplied by this number multiplied by 15.9, which is 9.66. Just let me do the first one more time. 15.9 cos of 142.6. Yeah, that's correct. Now these two, 18.5 times cos of 71.4, which is equal to negative 5.9, and negative will go here also. This will become negative down here to negative sine of 71.4 times it by 18.5. So that will be 17.53. So that's what I will get, and then I'll collect the like terms. This is J, and these two are the like terms. 12.63 plus 5.9, 18.53, and then 9.66 minus this number, because one is plus, another one is a negative number, minus this will be 17.53. I think I have to do this calculation one more time so that I want to make sure that I am on the right track. Minus 7.87 G. So sine of 71.4 times it by 18.5, which is 17.53. Yeah. So this is the number I'm going to get. Now I can find the R value. R value will be 18.53 square and plus 7.87 square. Again, I'm not going to worry about this negative. So this value will be, equal to 18.53 square plus 7.87 square, and this is square root of 405.3. So square root of this number, which is 20.1, 20.1 is the R value, and then tangent theta value will be y component, which is 7.87 divided by 20.1. Now y component is a negative one, so this will gonna go down. Y component is down, x component is a positive one, so I'm gonna draw it on this side. So my angle should come out to be in somewhere in fourth quadrant. So this value will become 7.87. This is 18.53 degrees, not degrees, number actually. 18.53, which, okay, 18.53 is also a negative number. If you see carefully, this is negative number, so 18.53 will go in the other direction, so I should not draw it in this. 18.53 will gonna go in this direction, and 7.87 in the downward direction. This is gonna give me the R value, which is 20.1, and this will be the angle. So 7.787 divided by 20.1, and second function tangent inverse, which is 22 degrees. Theta value will be approximately 21.4 degrees, I should say. So this angle is 21.4. So total angle will be, you add 180 to that, plus 180. So 201. Theta is 201.4 degrees. So the final answer will be 20.1 at an angle of 201.4 degrees. That should be your final answer. So hopefully you were able to learn something out of it. And I'll see you with another lecture video, and that will be the last lecture video on the complex number. Before I go, I must tell you the questions you should do. You should try and do question on exercise 12.6. You should try and do question 5 to 20. Question 5 to 20. These will be good enough questions from that one. Yeah, and then that's pretty much it if you can do that. And I'll see you on the other side. Till then, goodbye.